Today I'm going to walk you through on how to solve problem 2 of the HMMT Algebra and Number Theory round of 2021. We want to compute the number of ordered pairs of integers a and b with 2 is less than or equal to a and b, which is less than or equal to 2021, that satisfy the equation a to the power of log base b of a to the power of negative 4 is b to the power of log base a to of ba to the power of negative 3. Alright, so I've written down basically the three most confusing formulas that you'll need for this problem, and I'll explain them later as we go on. The first thing we need to do in this problem is take log base a on both sides. So log is a times a to the power of log base b of a to the power of negative 4. I should write that in brackets. Sorry. Brackets. This is equal to log base a of b to the power of log base a of ba to the power of negative 3. Right here. So now we can use our, the first formula we're going to use is this one. Log base a of a to the power of m is m. We see this connection on the left-hand side. This is a and this is a. All that's left here is the power. So the left-hand side just reduces to log base b of a to the power of negative 4. Sorry if that doesn't look so good right there, but right there. So, and we can further water down the right-hand side by using this equation. It states that log base a to the power of n of b to the power of m is equal to m over n times log base a of b. And we must apply it to this side. But you must be now asking, but wait, there's no power here. Well, we can see it as a to the 1 power. This divided by 1 is still that itself, so log of base a of ba to the power of negative 3, and then you just multiply it again by log base a of b. So now we can actually start reducing these things by using simple logarithm formulas. This is negative 4 times the log of base b of a. And now we can rewrite this whole thing. So we can break what's in the parentheses up. So log base a of b plus log base a. Sorry if that doesn't look good, but log base a of a to the power of negative 3 times log base a to the power of b. We see here that we can apply this formula again into this term here. That is going to be just negative 3. So now we can actually use some substitution to make this easier. We let x be equal to the log base a of b. Once we have that, this equation is going to be negative 4 times, well, this is basically it just flipped over. We wanted to have it like log base a and b. That's where our third equation comes in. It states that log base a of b is equal to 1 divided by log base b over a. So now this is just 1 over x, since those swap. And this is equal to, this is x here, x in the parentheses. And from this formula, we get that this term in the parentheses is just minus 3 times x. So now we have like a formula where we can just like simplify these things. We have to multiply both sides to get rid of by x to get rid of this x. So what we're left with is negative 4 is equal to x minus 3 times x squared. And we can multiply this out, factor it, and solve for the values of a and b. As you can see, I've erased all of the formulas because you don't need them right now. All you need to do is just factor and solve. When you multiply this out, you get x cubed minus 3x squared plus 4 is 0. You add that to the side. Now, once you've actually factored this by some method or another, you get that it's x minus 2 times x minus 2, which is x minus 2 squared, but yeah, you get the idea, times x plus 1 is 0. So now we have two cases here. Our first case being x plus 1 is 0, x is negative 1. Well, what is x? Earlier, we let x be log base a of b. So, therefore, log base a of b is negative 1. B is equal to, well, a to the power of negative 1 is 1 over a. We see a problem here with this one. We were given that a and b have to be integers, but in this case, for every positive integer here, it's not an integer here. Well, so because it's a fraction. So we know that 1 is wrong. The first case is wrong. So let's consider the second case. When x minus 2 is 0, x is 2. Seems reasonable. From this, log base a of b is 2. And from here, we get that b is equal to a squared. So now we have to consider the cases. A, b, like the least value of a can be 2. So it's 2 and 4 since they have to be squared, 3 and 9, all the way to some end value. What we really need to find is like how much of these combinations there are. So what we do here is we take the floor of the square root of 2021. That's like 44 point something. Take the floor of that and subtract 1 from it to get our answer, which is 43. So there are 43 cases here in which this works.